infinitesimal calculus. And for short, now we call it calculus. Okay. For example, can we compute the volume of a light bulb? It's not a beautiful one, but you can see it here, somehow like this. How can we compute the volume of this? Do you have any idea? Yes. Perfect. It's a great idea. Pour it water, and you measure that water with some measurement, which will give you the fastest way to measure this volume. Perfect. So we will use water to measure it, right? But as a mathematician, we can use calculus to compute it. By approximating it with by some polynomial and compute the integration of that, which is more complicated, right? And which is the branch, a branch of calculus. And another problems we may deal with will be the tangent problems. For example, if we're going up to a hill, which is like that, right? At the top of this, we're biking, right? And this hill, we want to know how stiff it is, which we need to compute the slope of this. With a measurement of the slope, we'll tell you how stiff it is. Okay? Or this branch we call, in order to compute these, we call it this branch differentiable calculus. Okay. So in some other cases, we may need to compute velocity of something. Sorry. It takes us some time to get used to it, right? So, for example, another, the velocity one. Sometimes you need to go through a bridge. You drive through this, and below that will be water. And your car is here, right? We want to drive it safely. We don't want to get into accidents. If we go this way, we may have to compute the maximum velocity that allows us to go and ensure that the wheel, the tires still touch the ground. Otherwise, it may go up and drop down is very dangerous. Those are some examples requires to deal with calculus, right? And now let us go to the very first chapter, chapter 2.1. In this chapter, we will study the tangent line. And velocity problems. Okay, so let me remind you some concepts you may know before already. So the first one is tangent line. What is a tangent line? Do you remember? Anyone want to answer this question?
Is it whenever it only touches one?
Perfect. The lines that touch our given graph at only one point. Tangent means touching, right? And it just one intersection. And here, in this circle, the line touch this point, touch this circle at only one point. So this line is a tangent line of this circle, right? How about we are given an ugly one, like this. And we are asked to find the tangent line at this point, right? So at this point, tangent line cut the graph at only one point. Therefore, the tangent line should be like this, okay? How about this guy? Is it a tangent line? No. Why? Because it touched the graph here at 3 points, right? So for these, we call it secant line, okay? So a secant line is a line that touches the graph more than 1 point. Okay. Another concept we need to remember is, can you follow? Is it too fast or too slow? Very good, thank you. Let us continue. Okay. So the concepts I just remind you previously is the slope. We just talked about this a little bit. So if on the 2D graph, we're given 2 points, P, and suppose in two-dimensional, this axis is X, this axis is Y axis, and the origin is right here. We are given the point P with the coordinate X1, Y1, and let us play with a specific number. Okay? Suppose this is 1, 1, and the point Q will be right here. This is 1. Sorry, it's not a good. I will draw a better line. Okay. And Q here, this is 1, this is 3, Q at 3, 2. So, the line that goes through these points is this guy, right? And here is the change in X direction. Can you see? And here is the change in Y direction. So we define this one, M. PQ is the slope of line segment PQ, go through these 2 points, is the change in Y direction. Divided by the change in X direction. Okay? So in this case, what is the change in Y and what is the change in X here? Any idea? So the change in Y is the coordinate of P, Q minus the coordinate of P, right? Which is 2, this guy, which is 2 minus 1, right, in Y. And in the X direction, it will go from 1 to 3, or the change of this is 3 minus 1, okay? And it is 1 over 2. We call it the slope of the line PQ here is 1/2, right? Is it clear? Perfect. And now, so we can conclude that the slope of the point P 1, 1 and the point Q 3, 3, 2 is PQ equal to 1/2. Okay. Now, let us move on to an example about the secant lines. Now find the equation of the secant line to a curve y equal to x squared plus 1 with intersection points. Okay. Intersection points at x is equal to 1 and x is equal to 2. Okay, this is the question. Can you see my handwriting? Hopefully it's not too bad. Okay, now so in 2D, in order to make a graph of a function, what you need to do is to pick some values, right? For example, if x is equal to -1, then what is y? Just put that value into this formula here, right? -1 squared plus 1, which gives us 2. Okay? How about at x is equal to 0? What is y? Perfect. 0 squared plus 1 will give us 1. And at x is equal to 1, perfect. 1 squared plus 1, which is 2. It means we can graph it, and it is at 1, it will be 2, at -1 would be this guy, and at 2 it will be 5, will be somewhere here. So the graph of this guy will be like this. Okay? Now the question is intersection of the point x is equal to 1 and x is equal to 2. It means it has to go through this point so okay, this point here. From this graph, it's not very a good graph of this, but we know that the line should go through somehow like this, right? The graph should cut at 2 points, let us say, let's go through this. Okay, this is a line segment cut. This graph at 2 points is given here. So let us call the first point P at x is equal to 1, right? And y will be 2. Perfect. And the second point, we call it Q. At 2, put into the formula, 2 squared plus 1 would be 5. Perfect. These are the points. We need to draw a line through them. And so what we need to do in order to draw a line of this, we need to know the slope, right? And the slope of that, P and Q, will be the change in y, or we can write it y2 minus y1 divided by the change in x, right? And in our case, we call the Q is the second point. So it means that it would be 5 minus 2 divided by 2 minus 1. Yes. Okay. And what is it? Yes. 3 over 1, which is 3. Okay. Now we know the slope of this guy. Okay. Let us put it here. The slope here, like this, right? M of PQ. And here is our P, and here is our Q. We know the slope of this, and for any point that belong to the line segment that we need to find, the secant line. For any point belong to this, it has the same slope, right? They will all have the same slope. It means that we call any point here, we call it the point N, X, Y, okay? It means that the slope of Pn will be X minus Y1, Y minus Y1, and X minus X1, which is, and this slope, we know that it will be the same as 3 here, right? Which means Y minus Y1, which is 2, divided by X minus 1. Okay. From this, we multiply both sides, or you can write this. Or y minus y1 will be m times x minus x1. For those who do not remember formula, you can think of this way like I do, so that you don't have to memorize it. But it's clear if you remember this formula, just put it here, right? With the same thing. It means that y minus 2 will be 3 and x minus 1, which means y, this is the equation of the line, or you can write it y equal to, you distribute this, and which gives us negative 3 plus 2 both sides. You simplify it, and we get 3x minus 1 here. Okay? This is our secant line, satisfying the requirement of the problems. Thank you so much. I think we finished the first class. And if you have any questions, don't hesitate to send me an email, and I'll see you tomorrow. Yeah, it's tough, so take care. Yes, please turn in the quiz on the table right here, and you can leave. Thank you. You have a good one. See you all.
Can you read my handwriting?
Sure. That's good. Thank you. Bye, Daniel, and bye, everyone.